So let's go ahead with okay, so I think we've done all of this, right? So the next thing says super simple shell. So using everything we saw, write a first version of a super simple shell that runs commands with their full path without any arguments. Have we tried this? Guys, have we tried this?
Yes, we did.
Okay.
Right.
That's a good one. So I'll leave us to do this on our own, okay? I'll leave us to do this on our own. This is you applying everything that you've learned so far. Did you attempt this? It says write a program that executes the command ls tmp in 5 different child processes. Each child process should be created by the same process, that's the father, and wait for a child to exit before creating a new child. Did you attempt this?
No, I didn't. I did not. No.
I believe we can attempt this. We did something similar yesterday. So it's just for you to wait. You should always wait before. Do you understand? We should always wait. Let me just do this here, but I'll leave us to do this on our own, to do the super simple shell on our own. But let's do this. Okay. What would we name it now? So I'll name it exec fork and wait. So remember to include all the necessary includes. So include uni std.h, include sys types .h, include sys weight .h. What else? We're not printing anything, so let's continue. So our path is okay. This is our string. I'll create it like this. So remember guys, this now is a single string. So with all what we've learned before, we should split this string into tokens, right? So we need a tokenizer. So because this is a short string, this is not actually much. We know what we are doing. I will not want to waste time, but okay, let me still do it this way. So let's create our you can decide what I want to. What we need is we need the string talk. So let me import our string. Let's include our string.h. Is this string.h or strings.h?
It's string.
Like this, are we? Okay, yes. So we can have a char. Token. So we can say token, or let's do it this way. Let's use a for loop. Token equals to str talk the path. Remember what else we need? We need a delimiter. So let's create our delimiter here. So for this string, the only delimiter we have is a space, right? We want to separate them by space, so just put a space alone. So path, then delim. Then we'll now say token so long as there is token, right? Or let me say token not equal to null. Maybe token not equal null. Why am I saying token not equal to null? Because at the end, string talk will return null if it gets to the end of the string and there is nothing else, no other string after a delimiter, it will return null. So that's why we are terminating it if we encounter null. Yeah, we'll say token. So what happens after this? So we first call the first one. We call the first one, we include the path. So subsequent calls, you don't need to include the path anymore, but rather you include null. So you not use the same string again. So you include null, and then you pass in your delimiter. So now that we have this, what do we want to do? So we want AV1, or let's say AVI. So here we have to declare an integer here. Int I equals to 0. So AVI equals to so AVI equals to token. So we get the token. Once we get the first part, we first get this part. We will set it equal to the value of I at the particular index. So if I is starting from 0, so I will first be 0. So the first index of our argument vector will receive the first part. So after that, the loop goes on. The loop goes on and then finds this -L and puts it at AV2, and then finds temp and puts it at AV3. And then remember, the argument vector must be null terminated. Sorry, AVI this time. So I would have incremented to the next one. So we'll say equals to null. I'm expecting us to have an error here, but I want to go on. I just want to watch. I'm expecting that there may be a segmentation fault, because we have not. The reason why there might be a segmentation fault is because we have not allocated any memory for this char execve. Do you understand? So that there is no error, I'll just do that. So for me to do that, remember, if I call this str talk, we will affect the string. We will damage the string. So instead, what I would do is I would duplicate that string. So let me say path copy. I'm doing that so that I can still have access to the string. So let me first use the copy here. Then instead of are you saying something?
Mr. Olawale, yes, I want to say something.
Okay.
Yeah, I left the PC for a little while. I just came. So, please, this function, what are we actually doing?
We are trying to solve this question.
The fork. Okay. Fork
This one. This, write a program. This program is what we are trying to do. We are trying to solve this. sorry, where am I? Okay, all right. So our first task, let me clear this. What we will first do is we'll first get the number. We'll first try to get the number of arguments that we have inside here. So we know that this is 1, 2, 3. So this will be 3 arguments. But if we are writing a function that we can always reuse, so we'll just use this to count the number of arguments with the copy. So what would happen is that the copy would not be useful for us anymore, because everywhere there is a delimiter, it will have been replaced by a null character. So if we try to use it again, we would get errors. So that means we can free it. And the reason why I'm using free is, if you read about this strdup, it uses malloc to create space for what it is copying. So it will first create the space, and then it will now copy that string into that space. So that's why you need to free it. So now, since I have enough, okay, yes, since I now know with this, I will be the number, I now will be equal to the number of arguments that I have. So I can now create space to store it. So I can now say argv or av equals to malloc size of, we're using size of pointers now. Okay, we're using size of pointers, size of that multiplied by, because I'm going to need another pointer that will equate to null. I will need another pointer that will equate to null. So I'm going to have the number, the total number of arguments that I have, then plus 1. So multiplied by I plus 1. So of course, if this fails, if av equal null, return let's just say error. So if everything is successful, the first thing is that we will terminate our pointer, we will terminate our vector with null. So the last pointer will point to null. So we can now have a loop now. In that loop, we will need to introduce another integer. So here we could have let's have j. So let me just initialize j from here. J will also be equal to 0. So I'll have a for loop. So I can still use token. Token equals to still talk. So you know, I'm done with the copy. Now I can use the original path and the limb. So long as token is not null, so I'll just leave this as token. So this also means that you are saying so long as there is token, so it's equivalent to so long as token is not null. So I can increment j here, or I can decide to say, since we've been using token, I can decide to continue with token equals straight up null the limb, then I will now say avj equals to token. Then I'll increment j. So exec, no sorry, we've not called exec yet. So this is where we introduce a fork, right? So let's do our pi dt a. So down here we would introduce our fork. A equals to fork. Okay, so our journey is about to begin now. So we would start with if a equals to, if a equals to 0, we want to call exec, or let me put it this way, if let's do it like this, execve av0, so the first index, you know the beautiful thing about this that would happen, the beautiful thing about this is that if I do this and I run this, there will be an error. And the reason why there will be an error is that we have not dealt with path. We've not dealt with getting the path variable. So this path, if I just call ls, the path will not be found. Because we have not dealt with getting that variable, I will just add code it. Do we understand that? Guys, do we understand? No response. So hello guys. Hello, can you hear me? Guys, are we there? Hello? Please, can you hear me? Can anybody hear me? If you can hear me, please respond. Wow, that's serious. Alright, so we will call our execve inside a fork, right? So this is our first fork. So AV0, and then our environment for now is null. So if it fails,
I think you should have if it's equal to -1, or you don't need to.
if what?
If it's equal to -1.
Yes, very good question. So this execve returns -1 if it fails, but if it succeeds, then it doesn't return anything. So that means if this succeeds, then this line of code will not be printed.
If it fails, it will be printed.
So if it fails, it will be printed. So there is no need putting it in a condition.
Okay, now I understand.
So else, we would wait. So we are waiting, right? We would wait. And then, so this is our first one, right? He said we should do it 5 times. So we would wait and fork again. So let me just try to copy all of this. Do you understand? So else we will wait. So this waiting is we are waiting for the first child process to terminate. Once the first child process has terminated, we will call fork again, and then we will now still go into the child process and execute another one, and then we would wait again. So we'll just do this again.
So now we have 2 child processes.
We are not having 2 child processes at once. We are having 2 child processes concurrently. So one would finish. It's after the first one finishes, then it will give birth to another child process. How many times did they say we should print it? 5 different times. I think I'll just do this. They said they want it 5 times, so I'll just do this 3 times. I think I'll just do it 3 times. It's the same it's the same thing we need to learn. It's the same understanding.
Question, just wondering, is it possible for us to okay, no, I don't know, but the question was that is it possible for us to loop the forking a number of times based on a specified number of times? You understand what I'm trying to say?
That's another one. It's possible. Let's try to use a loop.
So it's counting for a particular variable, which is supposed to be 5 times, and then
so we can do
which is that 5th time terminate.
So we can do it this way. Then we can now say that's j, right? We can now let's introduce another variable of count equals to 0, or let's say count equals to 5. So right here, so what I did was else, right, wait, and then so we can just stop here. Now let's put all this into a loop. Thank you so much, Mr. Timothy, for telling us about the loop. We can actually loop it instead of coding everything. So we have 5 counts. So we are going to start the loop from here. So for we already have a variable c. So while c is greater than 0, c minus minus. So that's just it. So we can use this to do it 5 times. So a will first be set to fork, right? So if a is 0, it will do this, else it will wait. So it will go again, it will fork again. If a is 0, it will do this, and then so it will continue that 5 times. So let's return now. So I hope I don't have errors. A lot of errors. How come free is giving me error? So I didn't include std leave. Okay. error again. What's up with error? Oh. Okay, so we are coming down. It's because of these things that is one of the reasons I hate coding on Vim or Emacs, because you don't have anything, you don't have any IntelliSense installed or something. Okay, so the last is Para. What's wrong with Para? No, Para should not give us. Para shouldn't give us any issues actually. I think it's the stdio I didn't include. I thought I included that. Oh, sorry, I didn't include it. Okay, finally. Okay, so this is printing, but it's like I'm seeing an overflow. Okay, it's actually not overflowing. Can you see it, guys?
Yes, yes.
Yeah, actually.
So it's executed ls 5 times.
Yes. For us to understand, let me just include let me include something in the parent process. Okay, so finished execution. 1, 2, 3, 4, 5. So okay, so that's it. So at least one thing you would understand is how to execute your program in a fork, so that you don't quit your shell whenever you are executing a program, and also so that you don't create zombie processes. So that's why we fork, we wait, and then we call execute. So that's always how it should be: fork, wait. That's wait in the fork. You fork, you execute your program in the child process, you wait in the parent process. So just always do that. All right, so that's about that. So we do this on our own, right? We are going to do this on our own.
Okay, I have a question about.
All right, go ahead, please.
Copy.
Go ahead, please.
Can you hear me?
Yes,
Hello, can you hear me?
I can hear you.
I said I have a question about the path copy. Why did we have to create a copy to the path?
Okay, good. So let's reopen the code. Okay, so from the beginning, so this is the first path, right? This was the one we used. Now we needed to create a copy. Why did we need to create a copy? Because for this first time, the first time is for us to create our execve. For us to create our execve, we need to create memory. We need a memory space for that execve. So in fact, this program is not yet complete. Let me just correct the program before I go on. I just detected a bug there, and the bug is that we did not free execve. Yes, so at the end you call free. Why don't we need to free the whole vector? Why do you think we don't need to free the whole vector? We don't need to free the whole vector because this was what we used. This was what we splitted into execve. Okay, and what we splitted into execve was created automatically by the program. The only thing we did in execve was to create an array of pointers, and each pointer was pointed to a path. Do you understand? Each pointer was pointed into a part of this. So the first one was starting from this location, the second one started from this location, the second one started from this location. So that means what they were pointing to was a part of this was yes, is inside this memory block that was automatically allocated, and that will be freed when the program exits. Do you understand?
Yes.
Yes, so the only thing we are freeing is just the AV. But should if we had used it on the path copy, if we had used it on the path copy, it would have been much more tedious for us, in the sense that we would not be able to fully free. And I would say fully, okay, we can still fully free. We will just call the free on path copy alone. We'll call the free on path copy alone, and then we will free execve, and that would have done it. So the other thing, what I wanted to say, you were asking why we needed to duplicate it. When you call string talk, what string talk does is, while it goes through the whole string, when it locates a delimiter, this is our delimiter here, we only use a single delimiter by, which is space. So when it locates a space, it replaces that space with a null byte. And remember that a string is terminated by a null byte. So that means you break that string and then it becomes useless. Because if I do this and I replace this with a null byte, if I decide to try to print this path again, it will not give me the complete path. It will only give me from here to here. Why? Because this place now will now be a null byte.
Yes.
So because of that behavior, I copied it, because I'm going to I want to go through it twice. The first one is to print is to get the number of strings, and I need the number of strings so that I can allocate memory for the argument vector.
Why not use the star length?
The what?
The length of the string.
Why not use star? Oh, very good question. Everything that was going into my argument vector, right,
Yes.
is not this string I'm copying into my argument vector. What I'm copying, what I need in my argument vector, the argument vector is an array of pointers.
Yes.
So, and I need a pointer for each token. This is a token, this is a token, and this is a token. Do you understand? So there are 3 tokens, so I need 3 separate pointers. Do you understand? I need 3 separate pointers. If I should use string length will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
It won't give us the exact number of pointers.
Yes, so it's going to be more.
I get it now.
So this
we
one,
use the copy to identify the number of pointers we have, so we can allocate memory properly.
yes, we still use string talk. The first time we call string talk, right, that we pass the copy, we use it to get the number of tokens that we need to allocate memory for.
Yes.
Do you understand? Which was what this block of code did for us. So afterwards I freed the path copy. Why did I free it? Because we don't need it anymore. This was a dynamically allocated memory with malloc. So because we don't need it anymore, then I freed it. So now I called malloc for the number of pointers, which was I, but because in a vector is terminated by a null pointer, so I created an extra pointer which would have the value of null. That's the L+1.
Yes.
So this now gave us the size. So of course this was just a guard in case of failure. So we now have AV. So the last pointer, which will be the terminating pointer, was set to null. So then I now add a second for loop that calls string talk, but since I've used the copy already, I saved the original. I saved the original for this purpose. So I now call string talk on the original. and then the original now gave us all the tokens we needed. So with the tokens we needed, we can now go into the execution.
Okay.
Do you understand?
Now I get it. Thank you so much.
All right, any other questions? Any other questions, guys? Okay, I think no questions, right? So we can progress.